Hey guys, Jake here, coming at you with another math problem today. Here's the problem we're going to be going over today. The problem is if f of 1 equals 12, f prime is continuous, and the integral from 1 to 4 of f prime of x with respect to x is 17, what is the value of f of 4? So to do this problem, we're actually going to need to use part 2 of the Fundamental Theorem of Calculus. And this is actually one of the formulas on my Calculus 2 study guide. There's a link down in the description if you want to check out that study guide. But part 2 of the Fundamental Theorem of Calculus basically just says if we have some function f, which is continuous on some closed interval from a to b, then the integral from a to b of that function f of x can just be written as big F of b minus big F of a. And this will be the case whenever f, big F, is some antiderivative of little f. Or in other words, f, big F prime equals f. So this is what part 2 of the Fundamental Theorem of Calculus tells us. But how does this relate to this problem? Well, first of all, we are told that this function here, f prime, is continuous. So basically we're taking the integral from 1 to 4 of some continuous function. And, you know, part 2 of the fundamental theorem just requires it to be continuous from a to b. So in this case, from 1 to 4. But based on the fact that it tells us it's continuous, that basically means that it's continuous everywhere. So it clearly is continuous on the interval of 1 to 4. So since this function that we're integrating from 1 to 4 is continuous on that closed interval, we basically can say that if we take the integral of this function, in this case the function that we're integrating is f prime, if we take the integral of this function from 1 to 4, or from a to b, we can say that that is equivalent to basically plugging in our upper bound and then our lower bound into some function which is an antiderivative of the function that we're integrating. So we need to find some big F, which is just an antiderivative of the function that we're integrating. Well, the function that we're integrating is f prime of x, which basically means we're integrating the derivative of f. So basically what that tells us is, if we this might get a little confusing with the notation here, because the little f and the big F here are different than the little f that we have over here. So let's ignore this whole chunk right here for just a second, and let's think back to the problem that we're given. If we have some function f prime, an antiderivative of f prime is just f. So in this case, little f is actually an antiderivative of f prime in terms of this problem here that we have. So what that means is, using this fundamental theorem of calculus, we can rewrite this as f of b, which is 4 in this case, minus f of 1. And that's because this function here, f, is an antiderivative of f prime, which is the function that we were integrating. So based on part 2 of the fundamental theorem of calculus, we can rewrite this integral that we're given as f of 4 minus f of 1. Well, it also told us that that integral was equal to 17. Right, that was given up here. So based on the fact that we know that's 17, and based on the fundamental theorem of calculus, we know that that's equal to this, we can say that f of 4 minus f of 1 is 17. So it also told us, back in the beginning of the problem, that f of 1 equals 12. Right? And what we're looking for is f of 4. So if we know f of 1 is 12, and f of 4 is what we're looking for, we can plug in 12 for f of 1. We still have f of 4 here that we're trying to find, and we know that this is equal to 17. So now we can just add 12, and that tells us f of 4 equals 17 plus 12, which is 29. So like I said, this all came from my Calculus 2 study guide. There's a link down in the description so you can check that out, but that'll be a huge help to you as you work through Calculus 2 homework and study for exams. It'll really just help you save a lot of time through all that process. So go check that out. Link is down in the description. Thanks, and see you next time.